Hey guys, what's up? I'm here with another, English lecture from Biomolecule, and I've done the, Hindi one just a while back. So whatever suits to you, whether the Hindi medium or the English medium, you can go and check out. But this time, I'm talking about maltose, which is a disaccharide, and it's a disaccharide of alpha D glucose. So this is what I'll be discussing. But let me tell you what I'll be talking right here. I'll talking about again four of the very important fact about maltose. First, what maltose consists of. Second, whether it is reducing or non-reducing. Third, where the glycosidic bond is formed. And fourth, how many molecules of monosaccharides are used here. So let's go all of these one by one and see what maltose appears to be. So I've given the topic here. So like I was saying, maltose, the first thing is that a maltose molecule consists of two molecules of alpha D glucose. How do we get to know? That's what I'm going to show you. So suppose we have maltose here. We have maltose, and what we are doing? We are doing the hydrolysis of this molecule. So you do know what hydrolysis means? Dissolving a molecule into water in presence of acid. So what will happen? This will produce two molecules of alpha D glucose. Again, the other molecule is also the alpha D glucose. Right? Now, we need to find out how the structure, is actually developing. So let me draw the alpha D molecule here of glucose. So this is going to be the formation of glycosidic bond. So you do know what a molecule of glucose looks like to be. This is a molecule of, glucose. This is a molecule of glucose, in its Howard structure, where the first carbon is right here. This is the first carbon, and it has OH out here and H up here, right? And this is your, this is your second carbon here, which has OH out here and H in there. And there you have your third carbon. Third carbon has H out and OH in. I'll tell you one thing here. In case you have problem or you are new to my channel, I would suggest check out the previous lecture in the playlist, where I have described every bit of biomolecules in my way. You're definitely going to like it and definitely going to get your purpose served right there, right? So let's continue. So the third one has OH in and H out there. The fourth one has OH again out, H up here, and this fifth one, if you remember, it has CH2OH, the A chiral carbon, and H right here. So this is your one molecule of alpha D glucose, right? Now we need to draw another molecule of alpha D glucose, so I'm drawing it right here. So this is your another molecule of alpha D glucose. So this is your another molecule of alpha D glucose here, right? And there you have your first carbon with OH out, H up here. So this is your first carbon again. Second one is right here with OH out here, H inside. Again, the third one has H out there, OH in. This is your fourth carbon, and the fourth one again has OH out here, H up there. And this is your last carbon, where the sixth one is out here at CH2OH, and there you have your hydrogen. So this is again your alpha D glucose, right? Now we need to find out how the bond between these two molecules happens to be. So the first thing you need to go early is that both of these molecules use their first carbon, and the second one uses its fourth carbon. Right? And this way a bond between these two is formed using the oxygen. So a glycosidic bond is formed between first carbon of one glucose and fourth carbon of another glucose. Let me show you how this bond is formed right over here. So since both of these molecules are glucose, so what we can do, we can take proton from anyone. So proton from there and hydroxide from here has been taken out, and they will result formation of H2O. And after the water, water has come out as a byproduct here, what will happen? This oxygen, will make a bond between these two molecules, and this bond is called your glycosidic bond. This is your glycosidic glycosidic bond. Glycosidic bond. So there the bond is forming between first carbon of one glucose and fourth carbon of another glucose, and this bond is again called glycosidic bond. This is also called dehydration synthesis. What this is called? Dehydration synthesis. Dehydration synthesis. Pay attention. This is really important, and at the same time I believe it's quite an easy. Dehydration synthesis. I must remind you that it's called dehydration synthesis because a molecule of water, while the glycosidic bond is formed, is released out as a byproduct. So that's why it's called dehydration synthesis. So this is what maltose looks like to be. Now we need to talk about the third very important thing, and that going to be whether it is a reducing sugar or not. So pay attention here. Both glucose has hemiacetal, right? So if you take a look here, the second glucose has its hemiacetal right here. So the hemiacetal of second glucose is not changing at all. So hemiacetal remain there. However, the hemiacetal structure of the first glucose has now been utilized. What is the hemiacetal? Just pay attention here. There, this one glucose has first carbon here. This is your first carbon, and now it has OH. It has H now. It has H now, and it has ether now. It has ether now. But there is no OH here. There is no OH. There is no OH because that OH was used here in making the bond. So that's why the hemiacetal structure of one of the glucose was used here. But if you take a look here at the first carbon again, what you see, there is hydrogen, there is again OH here, and there is again ether also. So what that means? It has the hemi structure. It has the hemiacetal structure, right? It has hemistructural structure. What that means? That the first glucose hemiacetal has converted into acetal. Hemiacetal here, hemiacetal has converted into acetal, right? So this doesn't have, this molecule will not be acting as a reducing, but since maltose is a combination of both of these and there is one hemiacetal right here, so what that means, this will react with, just pay attention, this will react with toluene, this will react with toluene reagent, and therefore we can say that the maltose is a reducing sugar. So I am concluding this is also reducing. Let me repeat back here. See what happened, a maltose molecule is a disaccharide and it's made up of two molecules of glucose. Which molecule? Alpha D glucose. And there both of the alpha D glucose are using, one is using its first carbon, another is using its fourth carbon. So what is happening during the bond formation? One of the glucose hemiacetal is converting into acetal, but other molecule of glucose, acetal, is not forming. So what that means, the hemiacetal remain there. And if there is a hemiacetal in maltose, it will definitely react with toluene reagent, Fehling reagent and Benedict reagent, and on that basis we can conclude that maltose is a reducing sugar. Just like the lactose, it is also reducing. Sucrose was not a reducing sugar, right? So this was the overall story of the maltose. In case I made it real fast, what I would suggest, repeat it, right? It's just a 5 to 10 minute of lecture. You can repeat it, and I hope in the very second attempt you will have every aspect coming out right in your head, right? But one more thing I would add here, that if there is a problem understanding the facts related to maltose, it may be also due to you haven't watched the previous lecture, right? Because there are some basics, so that's why I would suggest go back and check out in case you are having problem understanding any part of this maltose here, right? So with this I must conclude this lecture right here. I would say thanks for watching, take care and have a good night.